One way that you can separate impurities out of a mixture is through the process of distillation. Okay, let me show you what I've got going here. So I've got a mixture, it's got blue dye, water, and salt, and I want to separate out the water. Okay, so I put it in this little round bottom flask here, and I heat it, and I cause it to go through a phase change. When it gets to 100 degrees Celsius, the water will go from the liquid to the gas phase, and it'll travel down this tube here. It's called a condenser. Now this condenser has sink water running through it. I've got water coming in, water coming out. It's not mixing with the vapor because there's a tube within a tube. The inner tube has the vapor, the inside tube does. The outside tube has the sink water coming in and coming out. So all the sink water does, the tap water, is to keep that inner tube cool. So we get another phase change from vapor to liquid again. So it goes from liquid to vapor as it's heated by the Bunsen burner. It travels down the inner tube of the condenser, the inside tube, that's being cooled by the sink water, and then it condenses back to liquid again, and the distillate, it's called now, is collected into this beaker here. You can see it dripping out the end. Now you can notice already the distillate is clear because the blue dye didn't vaporize. So I'm separating the pure water out of that mixture. Okay? Blue dye molecules are heavier, they stay behind. The water molecules, the hydrogen bonding is broken, it vaporizes, it condenses, and it's recollected, and the dyes stay behind. So I'm getting pure water up this end, or purer water, I should say, more pure water. Now the question is, what about the salt? Because not only was there blue dye in here, but I also added rock salt to this mixture, and there's salt in here. Well, one way we can test to see is to use a conductivity probe. Okay, got my laptop here, let me get it going. And I've got a conductivity probe. It's got a little metal probe inside here that measures an electrical current. And what I can do is I can test my impure mixture and see how salty it is, because the higher the conductivity number, you can see right down here, the saltier the solution. And I can test my distillate, okay, the solution that was vaporized and then recondensed. Let's test the distillate first. Okay, and you can see it filling in the graph here. It's running about 620 microsiemens per centimeter. So it's very low conductivity. There's not very much salt in this at all. Okay, so we know the salt didn't travel over. Let's check and just make sure that that first impure mixture was salty. So I stick the probe into my mixture here, and you can see it jumped way up. Okay, it's now up around 33,000 microsiemens per centimeter. So this is very salty. This is very salty. Okay, but once it vaporizes, the pure water vaporizes and recondenses, and I catch it out of this end, the salt stays behind. Okay, the point of this is that if you have a mixture, one way that you can separate the components out, or the fractions out of that mixture, is to distill it, cause it to go through a phase change into a vapor and then back into a liquid again. And different components of that mixture might fractionate at different temperatures. In this case, we can get this up to 100 degrees Celsius. That's hot enough to cause the water to go through a phase change, but not the big dye molecules or the salt molecules. Okay, they're going to stay behind. And the water's going to recondense then, and when it comes out the other end, I've got relatively pure drinking water from this mixture. Okay, and that's the process of distillation.